Good morning. Welcome to the next Open Cloudification webinar. Today, again, accompanied by our dear colleague and partner from ID Lab, Merlijn Sebrechts. Merlijn, good morning also to you.
Good morning.
It's the middle of the holidays at this point in time. I just came back, but there's actually quite a lot of interesting things that we are planning to talk about. So from my side, and specific short updates, Open Cloudification is a Flemish project supported by the Flyer organization, and which we do together with ID Lab, IMEC Gent, and the Beacon, next to ourselves being LSEC leader in security. The project is now 1.5 years underway, and the aim of our activities is really to make sure that open cloud technologies, cloud native technologies, open technologies are understood and recognized also by companies as a potential alternative for commercial software. We're specifically focusing on open technologies, but then related to cloud, because we do see that there is an interest and a higher demand from innovative technology companies, which are considering some alternatives next to the large cloud services providers such as AWS, Azure, Google, and so forth. With this project, we have been organizing different types of webinars, face-to-face meetings, seminars, and we will continue to do so for the next 18 months. In the end, what we aim to achieve is for companies like yourselves to get familiar with these technologies, potentially even start them out yourselves, and use the opportunity of the availability of this richness of technology to at least develop some proof of concepts and ideas. And we would like to support those developments as well. So if you have some activities in the lines and would like to get some additional support, then Open Cloudification is also here to provide that. It's a part of the Vallejo Cook program, which means collective knowledge transfer and further applied research in this case. So we have been working next to open cloud technologies also on security of those open clouds, how to do resilience and making sure that there's also continuity happening. Today, there's an interesting development that Merlijn wants to share, streamlined teams and platform engineering. So specifically towards what is key for developers in this domain, and how they can continue also in the reliability of the services. Stay tuned also for some other activities which we will be podcasting about. Not so long ago, we started an initiative that is basically there to support small and medium-sized enterprises in their migration towards different digital technologies, and therefore also including cloud, which we can support specifically also for their cybersecurity. And if you're more in the manufacturing domain, then the utilising activities will be able to also help you out in the wider range of industrial challenges that you might face. Relatively new is our activities for companies which are developing technologies, so basically vendors, where a new regulation is popping up called the Cyber Resilience Act. And specifically for that domain, we can support you in your further securing the products and services and underlying technologies that you have to be able to comply to the CRA, to the Cyber Resilience Act. But stay tuned for that. Probably Merlijn and I will be talking about that in a couple of months from here. With this, I'm happy to hand it over again to Merlijn. Merlijn, floor is yours, and please take us along with you on the journey towards a stream alignment.
Okay. I need permission to share my screen.
And there you have it again.
Okay, great. So can you see my screen?
Yes, we can.
Okay. So Good morning, everybody. I'm going to talk about streamlined teams and platform engineering. It's basically the move to cloud. It's not only a move simply about adopting new technology, but in order to do this move successfully, it's also important to also change a little bit how you structure your teams. That's what we're going to be talking about in this webinar. Specifically, I will first talk about the best way in order to change how teams work is to focus on process instead of fixing individual people. Secondly, I look at the first dimension of how you can change how teams work. That's basically what are people doing? What are their tasks? Streamlined teams and platform engineering are two innovations in that regard that are very interesting. Second dimension is looking at, okay, how much ownership do individual teams have? That's the difference between strong ownership or collective ownership. There's also the idea of internal open source that I will be talking about in the second part of this webinar. But first, my name is Marlijn Sebrechts. I'm senior researcher at IMEC. I help companies deliver software and trust to clouds and on devices. I'm also a lecturer at Ghent University, teaching things like systems design, open source ecosystems, and cybersecurity. And I'm also a big open source contributor, both on the process and community side. For example, I'm part of the Ubuntu Community Council, but also on the technical side. For example, I'm building WebAssembly system interfaces together with the W3C. So I talked a little bit about process, not people. What is this exactly? Well, it's the idea that bad behavior in a company often happens because of difficult processes instead of difficult people. Changing individuals cannot bring about systemic change. If there is systemic issues in a company, you cannot fix it by changing individual people. Instead, you have to update processes, update incentives, and update the culture of your teams. There are many names for this concept. There's even a few popular movies that specifically talk about this concept. But the basic idea is that put people in a bad system, and it doesn't matter how competent or how willing these people are, it will result in bad actions. Put people in a good system, and even some of the lower performance will turn out to actually bring a lot of value to your company. So the result is that if you focus on process instead of people, it also creates a lot of trust and transparency in your organization, because people are not afraid anymore in order to talk about their own mistakes, in order to figure out the root cause of issues, because they know they won't be personally affected. Instead, as a team, as an organization, we'll look at how to actually improve the functioning of this team. It's also much easier to scale. It's much easier to fix a process and then have that impact how a wide array of people in your organization function, instead of having to address individual issues with individual people. And it can result in much more long-lasting progress, because this process, it keeps reminding people of how to actually perform better. One of the examples is the issue of blame culture. Let's look at a famous outage a few years ago, where basically almost the entire country of Australia was unavailable, didn't have internet, didn't have telephones, and this even affected emergency lines. After this happened, I think she's the CEO of the ISP responsible for this issue. did a big press release and explained that, yeah, it was an individual node that caused all these issues. We took that node down. Unfortunately, there was one individual in our organization who did not follow the correct procedure. He reconnected customers to the malfunctioning node rather than transferring them to one of the 9 redundant nodes. We have 9 redundant nodes, so this shouldn't happen. So we apologize right across our customer base. This is an embarrassing human error. Well, what do you think happened after that? They probably fixed that one person and everything went well. Well, actually, the exact opposite happened. On February the 9th, the original multi-hour outage happened. In March, they had 2 multi-hour outages. In May, they had 1 multi-hour and 1 multi-day outage. And in June, they had again 3 multi-hour outages. This kept happening until basically senior leadership stepped down from that company and new leadership came in and actually fixed the process instead of blaming it on individuals who did not follow the correct procedures. So yeah, what went wrong here? Well, it's the issue of blame culture. If the CEO of your company for a major outage goes to the press and explains, oh, this is the issue of a single employee, then inside of your company, you have a culture of fear. And a culture of fear makes sure it's one of the best ways to ensure that you will never know the root cause of issues because people are incredibly afraid to talk transparently about things that went wrong because they are afraid of losing their job. So people start to hide issues, they hide mistakes, and they cover their own ass. As a result, it's incredibly difficult to find root causes. You have useless postmortems like, oh, this individual did something wrong. You cannot learn from failures and you're sowing large distrust in an organization. And so a very easy design pattern in order to solve a lot of these issues is the concept of a blameless postmortem. The goal of a blameless postmortem is to have a detailed account of what actions people took at what time. It's not really important who took this action, but it's important to look at what actions were taken at what time. What effects these people observed, what expectations they had, what assumptions they had made, and their understanding of the timeline of events while it was occurring. And the important thing is that they can give this detailed account without fear of punishment or retribution. So it's basically the idea of finding the second story. The first story is always, oh, this failure was caused by human error. But then the second story, once you start to dig deeper, is that, well, human error is actually just the effect of systemic vulnerabilities deeper inside of the organization. How can it be that if a single operator accidentally fat fingers something, that the entire country goes down for more than an hour? This should not be able to happen. The system, the processes should not allow this to happen. So definitely, if you're interested in this kind of design pattern, look at blameless postmortems and a just culture. It's a very interesting explanation that goes a little bit more deep into how this works. But the reason why this is so important to look at organizational basically design patterns, that how your organization works, is basically because of Conway's law. It started as a joke, but it's actually something that you see happening over and over again. Any organization that designs a system, so that writes software, will design that system to resemble the organizational structure. And so it doesn't matter if you move to the cloud as an organization. It doesn't matter if you adopt microservices, as long as your organization doesn't change, as long as your team structure doesn't change, the actual end result will change very little, and you will not be able to take full to get the full benefits of actually moving to the cloud. I put this comic here just showing how different pieces of software work based on how the organizations actually work. But then people come to me, and often they are operations people. People from the operations side, from DevOps side, from engineering side. Yeah, but the problem really is that our developers constantly break stuff. That's why our applications are so bad. Well, let me give you a second design pattern. How to ensure uptime? Well, ensuring uptime is actually a problem that you need to attack from two sides at the same time. First of all, there's a technical side. You need to build software that can be robust. But then secondly, you also need to build teams that have a strong culture of prioritizing uptime, prioritizing robustness. And that's where you often get cultural issues. And that's often why there's such a discrepancy between what developers are seeing as the root causes and what operations is seeing as the root causes of issues. And it's simply because in most organizations, developers are evaluated on project velocity. So how quickly they can release new features. This creates an incentive to push new code as quickly as possible, while operations are evaluated on how reliable a service is. This implies an incentive to push back against any changes because most failures happen because of new features or new changes on the code base. And that's what creates this cultural tension. Um, um, that's what creates this cultural tension. That's what creates this animosity between developers and operations, because they have completely opposite incentives. So this there's a lot of different approaches for developers and operations. Things like software fault tolerance, testing, release frequency, canary duration, and size. But the most important part is that both developers and operations are working on these things together. Because if they're not working on it together, then it doesn't matter how many of these features you adopt, your software will still keep failing. So how do you solve this? Well, one of the ways, one of a cool design pattern is the idea of an error budget. An error budget is specifically a design pattern to optimize the relationship between developers and operations. It's an objective metric agreed upon by both developers and operations about how much downtime should be allowed in a single month. And if this error budget is exceeded, if there is more downtime than the error budget allows, then at that point, operations can shut down the entire operation and not allow any new changes and only allow bug fixes in order to improve this uptime. And so as a result, this really helps align the incentives of developers and operations, because as long as this error budget is not met, operations cannot say no to a new release. And it's also in the incentive for developers in order to actually care about robustness, about uptime very deeply, because they want to keep releasing new features, and they can only keep releasing new features if these feature releases do not result in downtime. And as a result, something as simple as an error budget can really help solve the tension between developers and operations. If you're interested in these kind of approaches, I can definitely highly recommend the book Site Reliability Engineering, written by a few Google employees. And they also have a lot of presentations and talks about this concept. Then the next thing people ask me is, yeah, but don't humans just naturally organize themselves? Well, the answer is yes, and that's the problem. The first problem is that often humans, when they just start to organize themselves naturally, they look back often subconsciously at organizations that they've already been. Those organizations might have a completely different culture. Those organizations might have been failing companies. So you're not entirely sure if these naturally arising structures, if these are actually functional and useful structures, or if they're dysfunctional structures from a dysfunctional company. But the second problem with this approach of just letting teams naturally organize themselves is what we call the tyranny of structurelessness. It's basically the idea that structure always naturally arises in communities, but if this structure is not explicit, then you have unaccountable leadership. And so to make this a little bit more concrete, when something bad happens because of an organizational issue, and you have a team that just naturally organizes themselves, everybody will just start pointing fingers at other people. There's nobody who has the end responsibility for certain things. And so when it goes wrong, everybody will just say, oh, I thought somebody else was going to take care of that. It's also very difficult to onboard people. This is very important in startups and scale-ups to be able to easily onboard new people into teams. But if all these organizational structures are implicit, if you just have to be in the know about who to contact in order to get a new release out, then it's very difficult for new people because they have to constantly ask other people, okay, how does this happen? And then finally, it's also very difficult to actually grow leaders in your organization because a lot of people will feel very lost and will not feel as if they have even the authority in order to start doing things because it's not clear to them who has the authority. And so you basically get an in-crowd in your organization who can often function like quite efficiently, and then you have a whole bunch of people who are just orbiting that in-crowd, who are a lot less efficient in their job, simply because they have too little knowledge about how the organization is supposed to function. So to solve this, there's a lot of organizational design patterns. And as I said in the introduction, the first dimension is, okay, what are people doing exactly? How can you change the role of people in order to get better results, in order to get more benefits from the cloud? And one of the most important ones is loosely coupled organizations, loosely coupled teams. It's basically microservice architecture for teams. The idea is that each individual team can make large-scale design changes without having to ask for outside permission, can make large-scale design changes without having to do outside changes, can complete this work without outside communication, can release a product on demand whenever the team wants to do it, regardless of dependent services or dependent teams, and can do testing on demand without requiring an integrated test environment that other team services are also running in, and can form deployments during business hours with negligible downtime. So that's the goal. That's the goal of loosely coupled organizations. A great example of this is how a lot of universities in Belgium work. A lot of universities in Belgium, each research group is a completely independent organization, completely separate from the larger structure of the organization. The upsides is that research groups get a lot of freedom in how to innovate and how to teach and how to do all these things. The downside is that it's a lot harder to actually address badly performing teams. So you need a second solution. You need cross-cutting roles with broad authority across all these organizations and management backing in order to then actually address issues that happen in individual teams. But it's important to note that there is a presumption of efficiency. There is a presumption of competence. You basically assume that each team is doing their job very well until you see the opposite. And only then do you start to intervene from a higher level of the organization. This is also the idea of stream-aligned teams. It's the idea that a team needs to be aligned to a single value stream of work. It's the idea that in order to add a new feature into the product, the team itself needs to be able to just add this feature without requiring coordination with other teams, without requiring handoff to other teams. This has the benefit that teams can really speed up the time it takes them to release new features, because there is a lot less coordination allowed. But this also means that your teams will become a lot more heterogeneous. So you will not only, it will not be a team of only front-end developers. You basically need full stack teams where the entire team can create an entire new feature, including the front end, including the back end, including the database layer, and everything that's required for this new feature. Then obviously another question is, okay, but then how large do these teams have to be? And the general consensus is that smaller teams in general are better. There's a lot of literature that shows, depending on which research it is, it often depends on team size, but something like, for example, 9 people, that seems to be the limit for how large an effective team can be. Once teams grow larger than 9 people, you should really think about, should this team not be divided into multiple teams? Small teams ensure that everybody is focused on the same outcomes, because it's quite easy to actually align individuals in that team. It's much easier to stay aligned. It's also much easier to coordinate on work, because you can just very easily just talk to each other about this work. You don't need very complex, very heavy planning and process management in order to ensure that work is being coordinated. However, each team still needs this autonomy. It still needs to have the power to make decisions and the power to act without coordination. And that can also affect team size, because it's better to have a team of 15 people that are completely streamlined, that can completely create new features, than to have a team of 5 people who don't actually have enough knowledge, enough experience, and enough authority inside of the team in order to release features. Okay, so now you have all these stream-aligned teams. But what about these shared concerns? Because obviously, this means that all these teams will have databases. All these teams will have backends. All these teams will have frontends. How do you actually ensure that knowledge isn't completely dissipated across your organization up to a point where no team has enough experience in order to actually build well-functioning UIs? How do you solve this? Well, one of the ways to solve this is to then use another design pattern called communities of practice. The ideas of a community of practice is basically that maybe for one lunch every week, every member of every team who is working on databases, for example, comes together for lunch and talks about how they solve database issues in their team. For example, how to improve indexing in databases. During lunch, one of the team members can give a presentation about how they debugged a complex performance issue, found out that there were certain indexes in the database that weren't set properly, and then explain how to do that. And then all the people responsible for databases in the other teams can learn from that, can take that back into their team, and can then work on it. This is a much better way in order to ensure that this knowledge is actually shared than having all the database engineers in a single team. Because if they're all in a single team, then they might be expert on databases, but they're not aligned with the actual value streams of your product anymore. This way, the primary alignment are the value streams of your project, and then they come together in communities of practice in order to share knowledge about their specific technologies. So to conclude, communities of practice are cross-cutting groups that foster sharing and learning. They allow members to continually learn and grow, get cross-cutting feedback and identify issues, and it can be based on a lot of different technologies. For example, a Python community of practice or a Kubernetes community of practice. And here you immediately see the advantage of communities of practice compared to just putting all database engineers together in a team is that database engineers are more than simply database engineers. They might also do some Python programming. They might also work a little bit on Kubernetes. And they can actually join the Kubernetes and the Python communities of practice, even if that's not their primary expertise, but they can still learn from these communities of practice. Instead of the issue where they're on their little island and only thinking about databases. For example, regular meetings, how to do this, regular meetings to share tips and experiences, having shared forums, having shared channels in Slack, creating documentation, creating best practices, and sometimes community of practice actually come together to work on technical stuff like shared tooling. A second concept for these cross-cutting concerns are enabling teams. Enabling teams basically solve the issue of each team has a completely different technology stack. How can we support them and fix structural issues in the technology stack? For example, how can we build CI/CD that can spin up a database with test data? Every single team needs databases with test data, so it's better for them to actually come together and build this together. Well, these enabling teams, they can really do that. They're teams whose only responsibility it is to work on enabling other teams. They can work on cross-cutting issues like security, like compliance, like performance. Very, very important to have security and compliance as a cross-cutting enabling team. And they can have interfaces, they can function as the interface between teams, and they can also work on the platform, for example. All of these design patterns, there's a lot more of these team design patterns. I can definitely recommend Martin Fowler's blog posts about team topologies. There's also a very good book about team topologies that I link to at the end of this presentation. But this is basically an overview of how some of these teams work. It's not because you have stream-aligned teams that there is no possibility anymore for teams to work together. Here you see you have enabling teams that actually serve as facilitators in order to build stuff that then other teams can use. You have the platform team that builds the shared platform, and then you have a complicated subsystem teams where multiple streamlined teams need to cooperate on a certain subsystem. This is how everything fits together. But then I talked about the platform team, but let me dive a little bit deeper in a platform team. What is a platform team? It's a team that runs and manages the platform. Sometimes this team is called delivery services, or delivery support. The idea is basically that developers are the users, and this team almost operates like an internal consultancy in service of the other teams. A great way to do such a team is to use the concept of a paved road. You clearly communicate how you want things done to the different stream teams. You clearly communicate how you want things done and provide mechanisms whereby these things can be done easily. For example, TLS, logging, auto-scaling. As the platform team, you can provide services, code, libraries, middleware that implement all these things exactly as the other teams should do it. This give and then you give these technologies to the other teams. This makes it very easy for the other teams to actually do the best practices, to actually implement the features, the security, the auto scaling that you want. But at first, you don't force developers to actually use these solutions. What you force developers to do it the way that you describe how to do it. You force the developers to use a certain TLS version, for example, to do zero trust communication between microservices. But how they do it, that's up to them. How they do it, that's up to them. But you give them software that allows them to do it very easily. And so if you do it in this approach, then you see that very, very quickly, a lot of developers will start to adopt the tools that the platform team gives you. The tools that the platform team develops. But some teams will not be able to use these tools because it doesn't work for their use case. It doesn't work for their technology stack. And then at a certain point, you really see that some of your teams have adopted this, other teams have not adopted this, and then the platform team can go to the teams that have not yet adopted it, and then see like, okay, which specific issues do we need to solve in order to get you to adopt this tool? So a couple of tips for a platform team. You shouldn't require teams to use this shared platform initially, because initially the platform will do less than what your teams can do themselves. Initially, the platform will not be able to encompass every single use case. And if you force developers to use the platform at that point in time, then you will not get a lot of buy-in from the developers, and developers will find every single side channel in order to do things differently, in order to not have to use the platform, in order to not have to use these technologies. But then once, for example, you see that 80% of your developers are using this technology stack, that's often the point at which you can start to force developer teams to actually start using it and go to the few teams that are not yet using this platform, and then ask them like, okay, what needs to change, what needs to be updated in order for you to also use this platform. It's also very important to actually keep monitoring the objectives. For example, how many teams are using this platform? How many teams are using our autoscaler? Because if you don't even know how many teams are using it, the platform team will never know if the things that they are building, if they're actually useful to the developers. It's also very important that once you force developers to start using certain technology, to start using the platform, that you explain why. You don't need to create arbitrary barriers just because. You just simply need to say like, look, in terms of compliance, in terms of security, it's very important that we can simply do one change in the platform in order to improve the security of all our services. So that's why you need to do this. You also need to clearly communicate specific requirements that teams need to obey. For example, how to encrypt private data. For example, how to do auto scaling. And then the platform provides an easy way to do it. And then you'll see that this is not a slide from me. This is a very interesting slide deck that I put the link down below. very easily you will start to see that there is basically a level of platform maturity. You start with ad hoc. Start with teams that are basically doing everything themselves inside. They are building autoscalers, they are building routers, they are building reverse proxies, they're doing everything themselves. Then you have a proof of concept where the platform team starts to build the team, and you have a few teams that are starting to adopt it. And then at a certain point, you have really organizational-wide adoption. The platform is rolled out for all teams. There's mentoring sessions across the organization about how to use the platform. The implementation is governed and reported. And then you get into the sustained and repeatable platform. That's basically a sustained platform implementation across all teams. You have governance, you have tracking and reporting across all teams, and basically every single team is using the platform. So that's basically the platform of platform engineering. So that's basically, instead of saying this is platform engineering and then explaining how to get to platform engineering, I basically explained this is how you get to platform engineering. Platform engineering isn't this magical concept that's completely different from how we do DevOps, from how we do platform teams before. Platform engineering is basically the result of a mature platform team, a mature internal CI/CD team that was able to roll out this platform through the entire organization. So platform engineering is basically internal operations as a service. It's almost as if you have your internal cloud provider team. It allows you to get critical momentum in a team to improve the operations culture. It basically gets the operations team from fire brigades that constantly have to put out fires to actually building fireproof systems. It lets applications teams focus on business features. It aligns how the different teams deploy and operate applications, and because of that, it allows you to really address cross-cutting concerns, such as security, in a streamlined manner. And it reduces the skills gap, because it enables stream-aligned teams without every stream-aligned team having to also need an expert on operations. It's basically, platform engineering is basically just developers doing the right kind of operations. Because one of the key words of platform engineering is developer self-service. Developers need to have a self-service platform where they can deploy new services, create new infrastructure, deploy new databases themselves. You want developers to do things like be able to deploy request routers, be able to deploy reverse proxies, job queues, scaling infrastructure. Because if developers cannot easily deploy these services as components, as open source components, because every one of these problems is already solved in open source components, if the developers cannot simply easily deploy these components using the platform, then they will add these functionalities as features to the product. And that is development time that is spent on basically invisible features, fixing invisible problems that have already been solved, instead of actually working on the business logic, and instead of actually working on features that your customers actually see. So it's very important that platform engineering is not about having operations take over everything. Platform engineering is about putting operations in an as a service, manner towards the other teams, where they provide a self-service platform to developers, which allows developers to do the very basic operations, where they can deploy components that they would otherwise just implement inside of the application themselves. And that requires you to have an internal developer platform. That's this platform, the platform of platform engineering. That's this internal developer platform. The platform engineering team builds these services, builds the platform, builds these components, and then developers simply consume them, deploy them, use them in a self-service manner. So the customers for the engineering, for the platform engineering team, the customers are application developers, information security experts, compliance and infrastructure teams. Those are the customers of the platform. The goal is to solve the need to deploy and operate applications in production. It solved this by providing a scalable and secure and reusable self-service platform. It enables out-of-the-box complex deployment and operations using industry best practices. So it really speeds up the deployment time and really allows developers to release features a lot quicker and a lot more stable. But this platform is in a declarative, extendable, and comprehensive plug-and-play manner, so that developers themselves, they can very easily just explain what they want from the platform, and then the platform creates that, and the developers can continue to focus on business logic. So the value is that you get a competitive advantage by reducing time to market and reducing complexity, and are able to align cross-cutting concerns across the entire organization. So that was the first dimension of design patterns. The second dimension of design patterns is about ownership. Who owns code and who owns certain services? There's basically two methods of code ownership. You have strong ownership, in which each microservice or each regular service is owned by a single team. And if external people want to make changes to that service, they need to ask the team to make these changes. This doesn't mean that other teams can't write code, but they can never commit code to the code base of another team. So they need to use things like pull requests if they ever want to change a service of another team. Note that each team can own more than one service, but each service is owned by only one team. Then the complete opposite of that is collective ownership. Any team can change any service across your entire organization. This requires very careful coordination between teams to ensure that teams don't get in each other's way. I'm not saying that one of these two ownership models is the best ownership model or the most important one, but it's very important to think about the benefits and the drawbacks of each ownership model, and to think about what is strategically the best ownership model for certain parts of your code base. So let's take a deeper dive into this strong ownership model. Team basically decides themselves on what coding standards to use. They decide what programming idioms to use. They decide when to deploy software, what technology to use, what the deployment platform is. And so strong ownership allows a lot more local variation and experimentation compared to collective ownership. One of the examples is Amazon's two-pizza team. This is often repeated as a way to explain how big a team should be, but I think that's actually a misunderstanding of what this anecdote actually says. So at Amazon, they talked about how big should a team be, and they basically said the moment you cannot feed a team with more than 2 large pizzas, that's the moment your team gets too large. But it's not really about team size, it's about team autonomy, accountability, and entrepreneurial mindset. The two-pizza team is about equipping a small team within an organization to operate independently with agility. And so when the team gets too large, it loses that strong ownership because the team itself is becomes such a large collection of people where there is then collective ownership that it becomes actually difficult in order to make quick decisions, make strong decisions, make bold decisions. Then full lifecycle ownership is an extreme version of strong ownership, where a team does everything from designing, coding, deploying, managing, and decommissioning. Basically, every single team is a separate project or a separate company. Although many teams, like if you identify, like, okay, strategically, we need, for these services, we need actually full lifecycle ownership of these services for the teams. You shouldn't really see this as the end result, but you should see this as something to strive towards, because it can often take years in order to actually get there. It's more something aspirational, and it's not really required to get the full benefits of strong ownership, because strong ownership only over code already gives developers so many benefits and allow them to speed up delivery so much more, that it's not actually required to get to full life cycle ownership in order to get the benefits. Then the opposite of that is collective ownership. Any team can manage any microservice. The advantages are that you can very easily move people to where they are needed. I need to give a disclaimer about this, is that you have to watch out for the mythical man month. You cannot simply, when a certain task will take 2 man months, you cannot simply put 2 people on it in order to make it take only 1 month. But the pitfalls about this collective ownership approach is that it requires a lot of consistency across microservices, because otherwise teams cannot change certain microservices. If certain microservices are written in Golang and other microservices are written in Rust, the teams working on the Golang microservices will never be able to change the microservices written in Rust. So you need a lot more streamlining and coordination about technology stacks, about programming languages and things like that. It also incentivizes very tight coupling between services. So even if you do a microservice, even if you try to create a microservice architecture, simply because of how ownership works in your teams, you will result in a distributed monolith. Because if a certain team, if they cannot simply change code of another service, then they will do everything in their everything that's possible in order to ensure that their service does not have strong dependencies on the other service. However, if it's very easy, every single time you want to make a change, that you make the change both in your service and the service of another team, when that is very easy, then you will eventually end up with very tight coupling between services. This is not necessarily bad for every application, but it's something to keep in mind. Then just very quickly, the idea of this mythical man month. Work is often estimated as it will take this many man months. This is a trap because we cannot simply throw more people at the problem to make it go faster. It's very difficult to break certain work into subtasks so that people can work on it in parallel. It's very difficult to do enough internal coordination to ensure that efficiency is being held high, and it's very, very difficult to onboard new people onto completely different services and have them be productive from day one. It's also interesting to think about ownership at 2 different levels, at the team level versus at an organizational level. For example, at the team level, you could have collective ownership, where every person in a single team can modify every single line of code. While at the organizational level, you have strong ownership, where teams cannot modify the code of other teams. Or you could even have it in certain departments. Within certain departments of your organization, you have collective ownership. However, across departments, you have strong ownership. So it's very, very important to think about how to actually balance these two models, because collective ownership gives global consistency, makes it very easy to address cross-cutting concerns, makes it very easy to ensure compliance, to ensure security policies, while strong ownership ensures local optimization. It will likely, where you are in this on this line will likely shift depending on the context. For example, for programming languages, you might have much stronger ownership where teams can choose their own programming language. Whereas for cloud platforms, it's often very important to have collective ownership of decisions surrounding which cloud platforms you actually use because of significant technical investments, because of the difficulties of communicating, having services that communicate across cloud and things like that. And then you can use things like latency budgets in order to actually ensure that even within strong ownership, you still are able to ensure cross-cutting concerns like latency budgets. So the idea of a latency budget in this situation is that across multiple services, if you have multiple services that need to collaborate together in order to respond to a request, across all those services, you can say, for example, we want across all those services at most a latency of 30 milliseconds. So any request that comes in needs to receive a response within 30 milliseconds. But different services are managed by different teams. So how can you ensure that these different teams, that the combination, the collective combination of the resulting services of all these teams, that they still adhere to this latency budget? Well, what you can do is simply divide the latency budget between teams. And initially, you can just, if you have 3 services, well, then you divide the total latency divided by 3, and each team gets the total latency divided by 3. Their service should respond within 1/3 of the total latency budget. And then teams start working. And then like a week or 2 weeks later, teams get back together, figure out, okay, what is the current latency of my service and can we adhere to our team's latency budget? If that individual team believes that that's not possible, then that individual team can just say it on the meeting, like, sorry, but we need more than 1/3 of the entire latency of this request because of these and these and these reasons. And then other teams can take a look at, okay, can we further optimize our service so that part of our latency budget can shift to the other teams? That's how you can do a cross-cutting concern in strong ownership teams, basically by having latency being requests latency being a collectively owned concern, but then individual teams get strong ownership of their part of the latency budget. You also need a shared platform. Even strong ownership teams share infrastructure. Platform engineering is a great way. Basically, you can basically say everything that is above the platform is owned by the developer team. Everything that's below the platform API is owned by the collective platform team. So above the platform API is owned by the developer team. Below the platform API is owned by the platform team. That's another way to do strong ownership versus collective ownership of infrastructure. Then finally, the last thing I want to talk about is this idea of strong ownership. Well, how can you actually implement that inside of your organization? Well, interestingly, simply because of how open source development is required to work, because of how open source development works, you see that there's a lot of benefits for application architecture. I talked about Conway's law, that a piece of software always resembles, the structure of a piece of software always resembles the structure of the organization. And because open source software is developed in a very distributed way across the globe, across time zones, often with people who cannot communicate synchronously, who can only communicate asynchronously, what you see is that this also reflects in the application structure. The application structure itself also creates like these islands of loosely coupled functions inside of a monolith, or loosely coupled in a regular software development. Simply because it is so easy to just get up from your desk, go to your colleague who wrote a different part of the piece of software and talk to them about what the fuck is this piece of software doing exactly. Simply because this is possible, you see that a lot of closed source software is a lot more tightly connected than a lot of open source software, simply because of how the development happens. So there's a lot of organizations that actually try to replicate this open source development internally in their organization. This is very, very important for companies that cross multiple time zones, but it can still be very useful in small organizations because of the benefits on software structure. The idea of internal open source is that the source code itself is visible to the entire organization, to all the developers in the organization. However, the number of people that can actually commit to a certain service, that is limited. So each team can only commit to their own services, but the code of their service is visible to the entire development team of the entire organization. And so if an external team wants to change something to a service of another team, what they need to do is contribute pull requests, and then the team that owns that service can review these pull requests and approve them. One of the important considerations here is that reviewing and approving pull requests and new code takes time. It's basically a trade-off. You create the overhead of a gatekeeper, but you receive better code quality, and much more important, you receive a much more loosely coupled piece of software. Because not only will the quality of your code base improve, different parts of your code base from different teams will also interact less with each other and will interact less tightly with each other, simply because of this added barrier of requiring reviews in order to submit code to another code base. And so developers, they get incentives, they will do everything in their power in order to ensure that their service is not tightly dependent on another service, so that they can create new features without having to change other services. It's a great way to reduce technology debt, but in return, you will have a little bit more overhead for individual changes. What's important is that reviews should be done by peers. Reviews should not be done by team leads or anything. Reviews should be done by peers. And from the moment a new person joins a team, the next day they should do their first review. Maybe then that piece of code needs 2 reviews instead of 1, but it's very important that reviews are done by peers, because during a review, the knowledge exchange can happen in 2 directions. The person who is reviewing the code can learn from the person writing the code, but also the other way around. The person writing the code can also learn from the reviewer. It's also very, very important that you need to review everything. Either you review everything or you review nothing. Because only reviewing high-risk changes shows no increase in performance, in code quality, in any of the important metrics in research. And in some sense, it's also logical, because if a certain change, if high-risk changes require review, then developers will try to hide the impact of their changes in order to not have to go through a review. So either you review every single change or you review no changes. It's also very, very important that reviews happen as quickly as possible. And so this means that every single day teams need to have blocks of time that they spend on reviewing code. Another interesting approach here is to do pair programming, where the review and the creation of code actually happens at the same time. In open source and in internal open source, there's also this idea of maturity. Most open source projects are not publicized from the first line of code. A lot of open source projects actually even start out as a private repository before it's actually made public and is actually made open source. And that is because code bases need a certain level of maturity before they can accept external patches. Because if it is not clear what the superstructure is of a code base, if it's not clear how new features are supposed to work and are supposed to integrate into a code base, if at that point in time other people start to suddenly add new features, then you will get a complete mess of a code base. So it's important that before you open up certain code base to external contribution, that it's very, very clear what the vision is of the piece of software. What are the goals of the piece of software? What is the superstructure of the piece of software? What is the overarching architecture of that piece of software? So it's important when project starts out, this simply is not clear yet. It might be clear in the mind of the original developers, but before the code base has certain maturity, this will not be clear to external contributors. And so it's important to create and complete the first version internally before actually opening up to external contributions. This is something that's very, very useful in the open source sphere, but that's also very, very useful for internal in closed source, in organizations building closed source code. So if you want more information on these topics, there's a lot of very, very useful content about this. In some of the previous slides, I put some links to blog posts. There's also a very useful book called Team Topologies, which goes deeper into how can you structure product teams, how can you structure developer teams. It's also very interesting to take a look at Jono Bacon. This focuses more on the community aspect and the interpersonal communication aspect of teams, people-powered, and a new way to look at conflict resolution. Very interesting materials. And then finally, a large part of this presentation, a lot of the content of this presentation actually comes from the book Building Microservices by Sam Newman. If you read through the book, you will see that I've used some of the figures of that book. It's a very great book. I would recommend, though, to look specifically for the second edition of this book, because the second edition of this book is updated, but was written after COVID. And so it also reflects on a lot of the hybrid working and remote working and how that affects teams and how you can adapt teams to such an environment. So this was it for my presentation. It was a little bit shorter than our regular webinars, but I'm happy to give a little bit of time back to you. Are there any questions? You can use the Q&A functionality inside of Zoom in order to ask questions, and I'll be happy to answer them. Otherwise, you're always free to send me an email. I'm happy to do individual sessions in order to help you solve certain problems in your technology stack or in your team topologies. And finally, make sure to go to the Open Cloudification website. We have a lot of very useful resources there. All of our past webinars are also on there as recordings. And it also, for example, explains how to use our testbed. As Ulrich explained at the beginning of this webinar, Open Cloudification is a project that is funded by the Flemish government, where we can help Flemish companies in order to better adopt cloud, better move workloads to edge devices, and we are happy to help you even individually.
Thank you very much, Milan. That was very interesting, very useful, definitely for many people with many of those teams out there that could get some additional ideas on how to better structure their way forward. I had only one question. I haven't seen anything popping up yet from the other participants. Do you have some recommendations on some of the platforms, some recommendations on the platforms you've used to work with or you have already worked with, and or that you're planning to work with, which could be useful, and what companies should be looking for in terms of those platforms?
Yeah, so one of the big reasons why platform engineering is suddenly taking off right now is because we suddenly have a lot of very good open source platforms that are enterprise ready. And the main one here is Kubernetes itself. Not regular Kubernetes, but Kubernetes has a lot of plugins that make it very easy to turn it into an actual self-service platform for developers. If you look at companies like Amazon and Google, they have been doing platform engineering in turn for a very long time. But right now with Kubernetes, you can actually create very, very similar experiences as these large players are doing, just completely with open source software. With Kubernetes specifically, one of the interesting things to look at is Argo, for example. Argo is a project, Kubernetes native project that includes everything from CI/CD, GitOps to workflow management, job queues. It's a very extensive platform that can really help you to create this self-service functionality, to let a platform team create a self-service functionality. And then secondly, I just lost my train of thought. Yeah, secondly, in general, what you then need on top of regular Kubernetes is better management of authorization. And this is a thing where OPA, the Open Policy Agent, for example, can really help you in order to create this clear dividing line between what are developers allowed to do on the platform and what are things that only the platform team should build and do.
I'm also jumping in very quickly for another question. As you explained a bit during the presentation, there are ways to start thinking a bit more on how you can change like your organization in order to have something more directed toward what you were explaining today. Do you have any quick suggestion for, because as you could imagine, organization right now are already structured in a certain way. So if someone would like to try what you're recommending, what would be the very first step to take?
So what you often see is that organizations, they start out with like tests, almost A/B testing their organizational structure. This is an old example, but back when Obama was still the president of the United States, they had a very archaic, very pyramid-like organizational structure inside of the IT department of the government of the United States. At a certain point when the Affordable Care Act was passed, they had to have a platform for people to actually register themselves for healthcare, for the government-provided healthcare. And this platform was a complete mess. It was national news how much of a mess this platform was, because the organization was so bogged down, because the organizational structure was so inefficient, that it was just not possible for them to create a robust and reliable modern cloud application. And so what they simply did was just bring in a team of people very experienced with this modern way of doing organizational structures. They brought in this team, they looked at this single product, and then structured that single product more towards the platform engineering mentality, and specifically more towards stream-aligned teams. And as a result, they were able to experiment. They were able to figure out, okay, how do we use stream-aligned teams in a government context where there's a lot more compliance requirements, where there's a lot more regulations. They were able to experiment and figure out a better way. And in the end, the result of that team basically became a template, became a boilerplate for how other departments could restructure. And then slowly that started to take over the entire organization. And in order to do this, what you basically need is buy-in from senior management, buy-in from the CEO. If you have buy-in from senior management, then you can do like an isolated test in a certain team for a certain product or for certain features. And if those tests are successful, then you can basically start the trajectory in order to educate the rest of your organization and in order to evolve the rest of your organization.
Okay, great. Thank you so much, Merlin. I don't see any other question in the chat. So do you have anything else to add before we closing down the webinar?
Not necessarily. Keep in contact. Feel free to send me an email if you have questions.
Okay, perfect. Once again, thank you so much for today. As usual, the recording of this webinar will be available soon on our website on opencloudification.com. I would thank anyone that was present today and see you next time.
All right, bye.